For the latest in strategic affairs, subscribe to our YouTube channel. Click the bell icon for updates.
Hello and welcome to Strat News Global, and welcome to The Gist, our signature show on foreign affairs, security, and science and tech. I'm Surya Gangadharan, and our topic for this evening is the government's recently announced Deep Ocean mission. And for an explanation and a dialogue on that, I have with me Dr. Rajeevan, Secretary, Ministry of Earth Sciences. Dr. Rajeevan, pleasure having you, sir.
Thank you.
Before we get into the questions, sir, I'd like to put out a brief explainer on an introduction to what the broad contours of the Deep Ocean mission are. So basically, it has a number of objectives behind it. It is to study the deep oceans and explore them, study the role of oceans in climate change, develop sea mining technologies, which are very, very sophisticated and very high tech, study the deep sea biodiversity, study the oceans as a source of energy and fresh water, and the study of ocean biology and engineering. So that's briefly is what the Deep Ocean Mission is about. But to break all this up into something that an ordinary viewer can understand, I have with us Dr. Rajeevan. Sir, is this the first time we are embarking on a mission of this kind?
Yes, that's true. The first time we are embarking in this kind of mission. But as you know that we have been doing these ocean-related activities since early 1980s. 1982 was the year in which Department of Ocean Development was formulated. Since then, we have been doing a lot of work related to ocean, especially on ocean survey and some kind of ocean technology development. For example, we have developed desalination plants in Lakshadweep, and also we did a lot of work on Central Indian Ocean survey and try to find out the polymetric nodules and minerals.
Yeah.
But this Deep Ocean mission is much more than what we have been doing. It is a really a kind of a five or six times far better or far more equipped mission. And it is the scope of the mission is much more larger. And mainly because unless we do all these activities in mission mode with a large funding as well as large human resources, the objectives will not be met. Otherwise, we'll keep doing 200 crore kind of experiments every year. We may not reach the destination. We may reach the destination after a long time. So this is a mission mode. Next 5 years, we want to really achieve some good output and meet the objectives of the mission. And so this is a very long, ambitious mission.
Okay. Are we collaborating with any countries? Is this a joint effort?
Yeah, see, we will be collaborating. Already we have some collaboration with, for example, countries like Japan, US, and all. But they say, unfortunately, many countries and first of all, this deep ocean technology development or deep ocean exploration are not done by many countries. Only very few countries. For some countries like US, Russia, France, Japan, and China. These are a few countries who have been doing a lot of work on deep ocean exploration, developing deep ocean technology. And unfortunately, these technologies are commercially not available. You cannot go and buy it from a shop and use it. Yeah. So we need this kind of expertise from different countries. But unfortunately, many countries are not really coming forward to and help you. Because strategically, oceans are strategically important. It was like a space was strategically important about 50 years back. And no country was willing to share the technology. It's almost like a similar kind of status now we have for ocean. Many people may like to come and discuss ocean science, basic oceanography, but not the technology. Very few people are not really coming out. I had visited Japan, I had visited US, and I openly discussed with them whether you will be willing to share us some technology, know how to develop this technology. They very politely, may not be directly, they may not say no, but indirectly they say no, it will be difficult. And so we need to develop these technologies basically indigenously. There's no other way. Of course, we can get a few consultants and from here and there and to develop this technology, but we have to do job ourselves within our institutions. And also we can collaborate with institutions like ISRO and academic institutions like IITs.
So when we look at sea mining technologies, can you give some examples of what these are?
See, there is an international organization of UN. It is called International Seabed Authority, ISBA,
Yeah.
and it is based on Jamaica, Kingston, Jamaica, and they normally give this contract to different countries who can explore and for minerals. So we got two contracts. So both are somewhere near North Indian Ocean, sorry, Central Indian Ocean, south of India, and one is for polymetallic nodules, and which we have contract from last 15, 20 years. And the new, relatively new one is hydrothermal sulfide. Both are relatively new area. But at present, the codes of our protocol of the International Seabed Authority is that countries can only do the exploration, no exploitation or commercial mining is for example, what could be the environment impact on by doing the mining on the oceans. And we can do it only if ISBA is very convinced that by doing this mining, the environment impact on oceans will be minimum or it will not be there. That kind of understanding should be there. So polymetric nodules, we have about 75,000 square kilometer area. So we have been allotted. So we have done a lot of exploration. So we know what are lying there as minerals. And we have done also a kind of a preliminary estimate of what could be the economic benefits. It comes around 110 billion US dollar. If you really take all the minerals, all the polymetallic nodules out from that area of 75,000 kilometer and bring it up and do a kind of a processing, we can generate copper, nickel, cobalt, manganese, this kind of very precious minerals. As you know, the availability of these minerals from land area is very restricted now. So we can have around $110 billion economic benefits. But and also hydrothermal sulfide is a really new game. We are just started exploring it. We are not really estimated how much will be the. We just explore because it is all basically from volcanoes, small volcano chimneys in the Central Indian Ocean, and there the temperature could be 400 to 500 degrees Celsius. So exploring that kind of chimneys and finding out what kind of minerals are available is very tough job. We have just started the work. So deep ocean mission, there will be an important component on exploring the hydrothermal sulfide. Whereas polymetallic nodules, the survey has been almost completed. Only what we need to do is developing the technology to take the minerals out from the Central Indian Ocean, process it, and make it into copper, nickel, cobalt, etc.
Is it being done on a commercial scale today by any country?
Commercial scale, see, you can do it on your east, up to 200 nautical miles. Whatever you have, you can do it. No other country will come and trouble you. That it's allowed. But see, under our east, not much this kind of precious metals are not available, and so we need to really go into the high seas. Where if you go to international waters, then we are subjected to the protocol of the UN.
Laws of the sea,
ISPA comes into picture, and many countries have this kind of contract. And for example, China has at least 3 or 4 areas they have contract. Russia has a lot of sea. And countries like Belgium and all started doing a little bit, not much. And countries like PNG, Papua New Guinea and all is doing it, but under over there EEZ, not in the deep ocean. Deep ocean, no country is allowed to do any commercial exploitation.
So frankly, it seems to me that this is a very expensive proposition, going to deep seabed mining. Is it sustainable?
People have done, ISBA has done a lot of work, and they have, for example, given a big project to MIT US for finding out whether commercially is available. Because I know, as you said, that its technology development is very highly costly equipments. These are all, and also the technology, as I said, commercially not available. So when you start doing it, you will encounter a lot of difficulties. And but they have done a beautiful analysis, very extensive analysis. I remember I have attended that meeting in which the presentation was made in Jamaica. So they told that commercially it is viable. Commercially viable. It is, so you can technically go ahead. Only now worry is the environment. Otherwise, commercially the exploitation of minerals from deep sea water is allowed, and it is commercially it's viable.
Now, since energy and renewable energy, fresh water are huge concerns right now, I was looking at this mission objectives that oceans as a source of energy and fresh water. So, can you explain something over there? I mean, exactly what are we looking at here?
So Indian government is now focusing more on green energy, and for example, they are investing more on solar and wind energy. Same way, we can also do it for ocean. Okay, you can derive ocean energy and use it for some commercial purposes. And also, we can derive drinking water from this by doing desalination of seawater. We already implemented 4 plants in Lakshadweep Islands. It's an indigenous technology. We don't use any kind of technology which uses power. And it's basically it's ocean water, and we use the ocean thermal energy as a source of energy for converting into desalination of seawater. And 5 more plants will come up in Lakshadweep Island. So we want to do the same kind of technology off the coast of Chennai. And the thumb rule is that we need about 15 degrees Celsius temperature gradient. And in Lakshadweep Island, you can get it off the coast of maybe 300, 400 meters. But off the Chennai coast, you need to really go up to 50 kilometers to get this thermal gradient, because the slope is not very short. Whereas Lakshadweep Islands are just pillars. Just if you go about 100 meters above, the depth will be too high. Whereas in Chennai coast, East coast, it goes very slowly, the slope. So you need to really go up to 50 kilometers. So doing a project at 50 kilometer depth is a very tough task. And we have estimated the cost, how much it will be of making 10 million water per day, drinking water, 10 million liter water per day. And so we estimate it comes around 2,500 crore. That's the estimate. Because we have to take the water, to convert it, and bring it up to the coast, 50 kilometers to the coast. And you need to really carry the energy also. So we are trying to, there's a concept called ocean thermal energy conversion. We can really generate electricity. And that electricity can be used to make it a desalination plant. This is the concept. So what we are planning now is, instead of doing a big project, investing 2,500 crore, because no country has done it. So if we're really doing it, we will be the first country to do it. It's a concept is good, concept is new, and but people are not really demonstrating. So we need to really do it. So what we are planning is about 100 crore we will be spending it to do a kind of pilot project. What are the difficulties available, and what are the difficulties which we can encounter? What are the other issues which we will be having? So it can have a pilot project. Once we, it's kind of technology demonstration. Once we do it, then we can scale up into a big project like 2005.
So this is basically desalination of water, isn't it? You're talking about desalination.
Yeah. So desalination water for Chennai city. But then the electricity for the desalination plant will not be used by the electricity also will be produced from ocean. So it is a completely green technology. Completely green technology.
But aren't the Arab countries already doing it? I mean, Saudi Arabia and all. They do a lot of desalination.
They are doing it, but they are using the concept called reverse osmosis, RO technology. And it is a highly environmentally highly adverse. And because it generates a lot of waste material, and it pumps into the ocean, and ocean gets polluted. And this is completely green technology. RO technology is very simple, and very simple means that you need to really use change the filters frequently, but investment is very small. And there are a lot of good technologies available, but it is highly polluting technology. It will pollute like anything. So we don't want that kind of technology.
Now, I read somewhere that you're looking at developing submersible technologies, that can go deep, 3,000-4,000 meters.
Yeah.
Is that something you're working on?
It's called a manned submersible, and only 5 countries have this technology. They have developed this manned submersible. And in US, there's an institute called Woods Institute. They have a manned submersible called Alvin, and it goes to deep bottom of the sea for very frequently. It's almost like a shuttle bus. They do it. China claims that they also developed it. Russia, of course, Japan has. And but this technology is highly complicated, because when we go down, what will happen means you need it has a lot of pressure. The pressure of the water. If you go up to 6,000 kilometers, you can just think of putting one bucket of water on your head, just about 2 feet or 1.5 feet water, and you can think about 6,000 meters of water on your head. How much pressure it will be? Too high pressure. So you need a special kind of technology. especially if you really want to go with your people. If you want to send the ROV remotely operating vehicle, it's okay. But if you want to send the people with that pressure, sustaining the pressure is very important. So you need to develop a sphere in which people can sit. The sphere should be susceptible and it should not break because of the pressure. So that is mainly made of titanium of about 8 centimeter thickness. The volume will be about diameter will be about 2.1 meter, and that technology is not available in India. So we are working closely with ISRO to help us to develop that titanium sphere. It's called titanium sphere. And remaining technology like electronics, navigation, and safety oxygen facility, all those things are we can do it. We are capable. Only the sphere is so the first aim of first important objective of this deep ocean mission will be to develop this manned submersible, which will be a first of its kind for the country.
So this we are developing it in collaboration with which country or institution?
Actually, for manned submersible, we are trying to work with ISRO now for the sphere, and also we are trying to work with Russia. Russia has this technology, and they are willing to at least they may not give you the complete technology, but they can at least come and help us in developing this technology. So we are trying to work with Russia also.
I'm a little surprised because we've been operating submarines for years, 30 odd years, and
but that submarine goes up to 300 meters. We are talking about 6,000 meters. So nobody has done it. India can have that technology. 300 meters, 400, 500 meters is okay. The pressure will not be that high. But we have the capability. Submarines, we can develop it. India has capability. But submarines normally go up to 300 meters.
So it would go as low as perhaps Challenger Deep and those kind of places.
6,000 meters, and there is a place called Northwest Pacific, West Pacific. There is a place called Marina Trench. It's about 10,000 meter depth, and China claims that they have gone. Japan claims they have gone up to 10,000 meters, and so people have the capability of going up to even 10,000 meter depth. But what we are talking about 6,000 meters because our minerals are available in Central Indian Ocean, which I mentioned earlier, is of the depth of about 6,000.
In the objectives, there's also this reference to the study of ocean biology and engineering.
Yeah, so basically, the biotechnology we know very well. There's a Department of Biotechnology here in India, and they're doing a lot of good work. So similarly, there is a marine biotechnology. You can use the fauna and flora of oceans. And you can do a lot of, you can develop, first of all, you can do the mapping of flora and fauna, biodiversity, and also you can do a lot of technology you can develop. For example, medicines, and we have a project called drugs from the sea. So you can take the molecules from different flora and fauna, and you can convert it into medicines, and it could be useful for even diseases like cancer, etc. So that is a new area where we will be working. Pharmaceutical, basically developing pharmaceuticals. It can be applied for pharmaceutical industries. And there are many other applications of marine biology. And we also know in India, marine biotechnology as well as marine biology, not many people are there. So in NIOT, Chennai, our institute, about 10-15 people are working. That's all. So we need to really develop more capability in terms of human resource development, etc. So we'll have under this mission, we'll have a training program and, for example, awarding degree, etc. in collaboration with foreign universities where this marine biology is very strong. So we'll be developing the human resource development in marine biology, so that many people can get involved and do research in marine biology. It's a very, very, very nascent area, very, very virgin area, marine biology, at least in India.
Dr. Rajeevan, that was very illuminating and informative.
Thank you.
With the very best to your very ambitious mission. I understand more than 4,000 crore is going to be invested over the next 5 years. That's a lot of money, and we are clearly looking at some over the horizon technologies, assuming that everything goes well. So, sir, thank you very much for this interview and appearing on our show. And for all of you out there, keep following us on social media, on Twitter. Give us your ideas, comments, and observations. We look forward to receiving them. That's all we have on the gist today. Thank you.